then we're going to say x cannot be -1, x cannot be 1, x cannot be 3, and y cannot be 0. So what I'm going to do before I do my interval chart, I'm going to actually draw this on the graph. Just because it's easier to see. It's much easier to visualize these things, and then get all the intervals and all that stuff. Does anyone have any questions on where those four things came from? No? Okay. Yes. Y in grade 11, yes, y can always not be 0. The reason for that is, right, in the numerator, for this to equal 0, the numerator has to be 0, and if -4 can't be 0, so it's going to be, yes?
You said x equals 1 rather than 9.
Oh, thank you. Okay, so let's go for my graph paper here now. All right, so I'm going to draw a nice little graph here. I have to get to 3 and to -1, so I'm going to draw something like this. Okay, can someone other than Liam, since you're going through it for the asymptotes, tell me here how I draw an asymptote on a graph? Okay, go ahead, Kristen. Dotted line. Okay, and you should use a ruler too. I don't have a ruler with me up here. I'm also going to ask you, even though it should be obvious what the asymptote is, please just label it on there to be, so that's going to be y can't be 0. Here's going to be x can't be -1. Here's going to be x can't be 1. And here's going to be x can't be 3. Okay. Are we sort of feeling okay about that before we begin? Okay, because this is the fundamental part. We need to get this, and I recommend doing this before your interval chart, just because it's much easier to see the intervals now. No comment means it's fine. Yes? Okay, no comment. All right, whatever. Okay, from starting left to right, what's my first interval going to be? Yeah, so I'm going to say here for this, this is going to be interval number 1, goes from there, okay? So I'm going to do my interval chart right now. I'm going to say f of x. And I'm going to put in here then, this is going to be x is less than -1. Okay, what's the second interval going to be, please? Yeah, go ahead.
X is greater than -1 and less than 3.
Very good. I'm going to say less than 1, not less than 3. Right, because that's just from here to here, right? Okay. So number 2 is going to be from there to there. Good. Can I get a third volunteer, please, to tell me what the third interval is going to be? Yeah, Alex, good.
X is greater than, less than 3, greater than 1.
Okay, great. So I write that as 1 is less than x is less than 3. Great. And interval number 4 is going to be over here. Okay, what's the fourth interval, please? Yeah, x is greater than 3. All right, now this is the part that you have to be brave now, okay? Who does not understand, please ask if you don't understand where those came from here. Just think of it like domain here, okay? So one hand at the back. So what we just said was the first graph is going to be what's happening on this side. So just if you look at your domain, if this is going to be -1, on that side it's going to be less than -1. So that's the first chunk. The second is going to be between the next set of asymptotes. So x is between -1 and +1. So just think like domain, the same thing. For number 3 then, it's going to be between +1 and +3. And number 4 is going to be on the right side, so it's going to be bigger than 3. Okay, so think of it just like you're dealing with domain, the same thing there. Okay. What do I write under the f of x column on the left? Yeah, Bailey, go ahead. x minus 3 you said? And overall, I'm going to write down test points. Okay, can someone explain where Bailey got those 4 things on the left? Okay.
We're in the original equation.
Right on. Those are like the negative 4 was the numerator, and x plus 1, x minus 1, and x minus 3 were the denominator. What's that? Test points, PTS. Okay, I can write it out though, sorry. Okay, so then what we're going to do, and you can pick any points you want, all right? But you're looking for a point then less than negative 1. I'm going to pick the points for you guys today for the sake of time. So I'm going to call that negative 2. I'm going to then pick a point between negative 1 and 1, which is conveniently going to be 0. A point between 1 and 3, which is going to be 2. And a point bigger than 3, which is going to be 101. Any points will work as long as they work within that range. Or within the main technically, okay, right? As long as they fit in there. Okay, there is one trick to this question. Why is this question different than the ones you got for homework last night and the ones we did in class? What's the difference? I don't see any difference. Yeah, Kelly, go ahead. 4 is negative instead of positive. Okay, every question we did yesterday was going to be positive. Okay, so the differences for this one is, no matter what number I sub in for x, negative 4 is always going to be negative. And that's why you need to include it there. Okay, right? So no matter what, because the negative 4, all it's going to do is basically flip the graph, right? So it's always going to go for negative. All right, can I get a brave soul that wants to take me through the first row here, please? Oh, no one's brave. Spidey's coming back here. The same 5 people. Oh my goodness, somebody new. Brad, I'm picking on you. Brad. What is negative 2 plus 1?
Negative 1.
It's negative. What is negative 2 minus 1?
Negative
3, which is negative. Good. Negative 2 minus 3 is?
negative.
What is a negative times a negative times a negative times a negative?
Negative.
Positive.
No, positive.
Good until the end. Okay, positive. Good. Brad, you're not done yet. How do you draw a positive? How do you draw a positive graph? What does that mean? Okay, it's okay. Somebody help me. What's a positive graph going to be? It's going to be upwards. Okay, so this one's positive just means it's going to be above 0, below 0, the entire graph. So the way that's going to go then is something like this. Oh goodness, sorry. Alright, so it's all going to be above 0 then. All right, Matt, it's your turn to shine. What is 0 plus 1? 1, which happens to be positive. What is 0 minus 1?
1.
Negative 1, which is negative. 0 minus 3 is? Yeah. And then a positive times a negative times a negative times a negative is going to be what? Negative. Okay. Now remember we're multiplying here, so the reason the first one's positive, I should have slowed down for that. A negative times a negative is a positive, times another negative is a negative, times another negative is a positive. Same thing there, negative times a positive is a negative, times another negative is a positive, times another negative is going to be a negative. So that, I'm sorry, too many negatives here, but that hopefully you understand what I said there. Okay. How do you draw a negative? Luke, go ahead. Yeah, it's not quite a problem, but yes, I understand what you're saying. Okay. So we're going to go on here, sort of like this. Now, for us right now, you will learn in calculus how to find that point. Okay, you don't know right now. We don't really care right now. Okay, right, for the maximum. Yes.
Why is it not exactly parabola? Like,
What a parabola would go is, parabola goes on the domain's infinite, right, for a parabola. But for this one, it isn't, right? The domain's like it stops. That only goes from negative 1 to positive 1. So parabola like would go on, get wider and wider and wider. This just sort of stops at this point. So it's not, I'd say it's not quite a parabola, right? It's very close to it.
so it's like a shortened cross
Yeah.
parabola.
There's a different name. I want to call it hyperbola, but I don't think that's right. Okay, but it's a modified parabola. Yeah.
Why is this in the second, like, column written like a parabola, but the first one is just like.
Yeah, good. Okay, good question. Because if you think the way that, if you think the way an asymptote goes, we did table values of this yesterday, right? As you get closer and closer and closer to a parabola, it's going to hit towards infinity. It's going to get very, very big. Okay, because there's nothing over here, it's going to come close to 0. That's how it's going to go. Okay, because remember we did the table and it was like -5, so it'd be like 1 over a big number is going to be almost 0. Okay, so if there's an asymptote, the graph's going to sort of gravitate right to that, but if there's no asymptote, it's just going to go right along.
So in the third one, it'll be the same as the second one.
Yeah, it'll either be upwards or downwards, we'll figure that out. And then the fourth one is going to be like either like this or like this. Okay. All right, Quinn, since I haven't picked on you since yesterday, here's the next one for me. 2 plus 1 is? Good. 2 minus 1 is? And 2 minus 3 is? Good. What is a negative times a positive times a positive times a negative? Good. Okay, so as we asked here, a positive graph is going to look something like this. Oh goodness. Sorry guys. That's not a good graph, okay, but I think you know what that's supposed to look like. So that's just only positive. All right, and Emily, can you do the last one for me? 101 plus 1 is going to be 101 minus 1 is going to be 101 minus 3 is. Okay, so the overall result is negative. Okay, most graphs, as you can see, are going to alternate. The only times things would switch is if there was like a squared in the equation or something. And I'll give you one on the assignment that is not like alternate top and bottom, top and bottom, top and bottom, okay? But you should actually use the interval chart to check. So negative 1 is going to look something like this. And again, I chose 101, right? But even if I would have chosen 3.1, 3.1 negative 1 is still, negative 3 is still positive. All right, Tristan, how you doing? Great. This sort of makes sense for most people. The negative at the top was the only check for this one, right? But beyond that, I want to make sure life is good. I missed the domain and range. Can someone tell me the domain and range, please?
Sorry.
Yeah.
X cannot be 1, 2, and negative.
Right. So basically all the domain and ranges, this is just your asymptotes, right? And my range is just going to be y not equals 0. Technically, someone's going to fight me here, but I'm not going to put up a fight. It's a little different technically because you don't know quite how high these go. All right, so you could argue with me, and hopefully no one will. It can be a little bit in between, but we'll just say the asymptotes we use for this, okay? Yes?
But in other things that x can be 0 when it crosses the 0.
Okay, you're asking the same thing yesterday, okay? In yesterday's note, why our graph, okay. On yesterday's equation, we graphed 1 over x, right? That was our original graph. So the reason for that x equals 0, like it's like the restriction, right? For this one here, again, as I was saying, it's always whatever's in the denominator, okay? So that's the difference. Okay, good. Did anyone show this to their parents and impress them last night? No one shows their parents at home. Okay. I would recommend tonight, Liam, you show your dad this graph, and he will just be knocked off the chair. Okay. And I don't want you to hurt your dad and knock him off the chair, so maybe don't show it to him tonight. Maybe wait till he's in a comfortable chair. Well, yeah, maybe stand. All right.
Or sitting in a nice comfy
Yeah,
chair.
maybe that's the best. Yeah. Yeah, definitely don't show it when you stand at the top of the stairs.
No.
Because I would do that. Okay, I'm going to pause this then, and then we'll get started with today's lesson.
Going